Let f of x be e to the x multiplied by x squared plus 2x minus 1. We want to find the first differential in the form e to the x ax squared plus bx plus c, and hence find the exact x coordinates of the stationary points on the graph of y equals f of x, showing full use of calculus. So this is a product. U is e to the x, v is x squared plus 2x minus 1. So du dx is equal to e to the x, and dv dx is equal to 2x plus 2. So f dashed x is going to be v du dx, so that's e to the x into x squared plus 2x take 1, plus u dv dx, which is e to the x into 2x plus 2. So that's e to the x squared, and we've got 2x here and 2x here, so plus 4x, and minus 1 here and plus 2 here, which means minus 1. So for f dashed x to be equal to 0, that means, since e to the x can't be 0, that x squared plus 4x minus 1 is equal to 0. Now we can use the cas for that, and we wanted exact coordinates, so make sure it's in standard mode, and we get that x is equal to negative root 3 minus 2, or root 3 minus 2. Just noticed I made a slight mistake here. This is actually a plus 1 here and here, but it doesn't change these results. I actually typed it correctly into the calculator. I'd just written down the minus 1 here. So the results are the same. We now want to find the range of values for which the curve is concave up and for which it is concave down. Again, showing use of calculus. Well, we need the second derivative for this. Now, if I work from here, then u is equal to e to the x, and v is equal to x squared plus 4x plus 1. So du dx is e to the x, and dv dx is 2x plus 4. So f double dashed x is going to be v du dx, so that's e to the x into x squared plus 4x plus 1. And then we need u dv dx, so that's e to the x into 2x plus 4. And if we put all that together, that's e to the x squared plus 6x plus 5. Now we need to identify where this is positive and where it's negative. And e to the x is always positive, so it's going to be to do with this bit. So if we think about x squared plus 6x plus 5, and you could use your cas just to graph it, but we can factorize that into x plus 1 and x plus 5, and then we can graph that manually. We could have just done it on the calculator, it doesn't matter. And so it's going to go something like this, negative 5 and negative 1. So what we can say is that this is positive from negative 5 backwards and negative 1 onwards, and in between here it's going to be negative. So we know that positive means concave up. So we can say concave up is for x is less than negative 5 and x is greater than negative 1, and concave down would be for x between negative 5 and negative 1.